Welcome back. Next up is Paul. Paul is an experienced software developer, passionate about TDD, his background happens to be art. He will share some interesting contemplation about how machine learning can impact our work in software delivery. I was also asked to note that he really loves his Scrum Master. Oh.
Yeah, hi, I'm Paul. I worked at NewVoiceMedia for 5.5 years. I joined the privilege. And thank you for having me at the Lots of Agile Development Conference. So I've treated this talk as an opportunity to learn something brand new to me, and that topic is machine learning. But I'm a complete novice, so nobody who enters this room will leave as a practicing data scientist unless you were one when you came through the door. As kids, my brother and I would perform chemistry experiments. This would involve finding an empty bottle, running around the house and filling it with all the things that we could find, shaking it vigorously and hoping for something, anything, to happen. We had no idea what we even wanted. So once the vinegar, the milk, that's off the shelf, the washing up liquid, the spaghetti had gone into this bottle. I think the best effect we could come up with was a noxious smell. And to be honest, I think you should expect results of a comparable standard from that. So why am I jumping on the machine learning bandwagon? Last year I had the experience of working on a project which depends on speech recognition. And it's also a foundation for us to build machine learning applications to provide insights to our customers. But as an application developer, kind of building this thing using microservices, the speech recognition element of this was kind of a black box, just something hidden away. And so that motivated me to learn a bit more and to open up that box and get to know something about the details. So my knowledge to date comes from the Coursera course by Andrew on machine learning. If you have a similar interest, then I'd recommend you take it up. So why did I call my talk Goodbye Scrum Master? It's kind of a parody or a satire. I don't really want to eliminate Scrum Masters, and they have a huge amount of value. And I'm sorry about this slide. The words very small, probably can't be seen from the back. At the time I was invited to come and talk here, I was reading a book called Your Code as a Crime Scene. And it's really interesting. The guy kind of draws analogies to forensic investigation. And he builds tools, uses his tools to analyze a source code repository. And by doing that, he's able to find what he calls temporal couplings between one part of the system and another. And these are kind of relationships that you might not know about from looking at the code. So maybe you need to change two completely separate microservices at the same time. This kind of analysis might flag that up. So that inspired me to think, what could we do if we were able to kind of pull in all this ancillary data and kind of assimilate it through machine learning or whatever other tools we use, and provide that as feedback to ourselves as a development team. And maybe it's a bit of a pipe dream, but it seemed interesting. Anyway, my confession today is that I haven't really taken that idea too far, and I've been more kind of distracted or engaged with the details of machine learning, so the rest of my talk will revolve around that. I'm going to play with ways that maybe I shouldn't, so I'm going to commit some agile sins. You shouldn't really correlate story points to cycle time. But I'm going to use data which I retrieved from our project tracking tool, JIRA, and use that as a training set for machine learning algorithm. And later I'm going to attempt to look into predicting story points for a new story using a neural network. So, where does this data come from? I work in a team called Connect Force, and we build features for contact center agents or sales teams and sales reps to be used so that they can use NewVoiceMedia in Salesforce. My team is made up of all developers, tester, a Scrum Master, we follow a 2-week sprint cycle. Use JIRA for tracking stories, and some of my colleagues are in Ireland, some are in the UK, so we collaborate remotely using GitHub. So I've retrieved stories that the team has worked on via a REST API, and we've played with that data with machine learning. So in machine learning, one of the kind of fundamental concepts is linear regression, where you attempt to fit a line to a training set. And this is the way it works. So my yellow blob on the left-hand side is my training set of all the stories. Each green dot represents a story. And we have to first come up with a model where we choose a line that we attempt to fit to this data. Then the job of the machine learning algorithm is to find the ideal parameters to fit that training set. So here I've plotted my story data. I have story points which we estimate on like a Fibonacci scale. 1, 2, 3, 5, and 8. And cycle time, which is the time from beginning to complete on the vertical scale. And so I need to find a way to draw a line through this data. And I could choose any kind of linear model. It could be a straight line, it could be a higher degree polynomial function. So we have y equals mx plus c. The job of the machine learning algorithm is to find the best data parameters. So we replace m and c, the coefficient and constant, with theta 1 and theta 0. And this function is called the hypothesis. And what this means is that given one story with, say, 5 story points, I can put that value into my hypothesis and it should spit out the cycle time. So how do we find the ideal fit? Well, we need something called a cost function. And the cost function is a way of evaluating the difference for a given a set of parameters and a known output for a story. How close is the model to predicting the actual result? So what this means is take all of the stories and see the difference between the outputs and the model, and generate a cost, which is actually like an average for all of that information, given the parameters passed to the cost function. Are you with me? So we pop the cost function, and the cost, the parameters passed to the cost function are plotted on the bottom, and the costs are plotted on the vertical axis. So you're going to see by doing this that the graph has a concave plot, and the minimum is where we find the ideal fit of the line to our training set. So the next step is to get a function that can iterate over different values of the parameters and seek out the minimum, which is the best fit of the line to our data set. And this is called gradient descent. And how it works is you select kind of random the algorithm iterates and continuously updates those parameters, but it uses the gradients to seek the minimum of the curve. So when I implemented this and ran it through my training set, this is what I found. We have a line that traces through our stories. And intuitively, it might make sense when I'm predicting story points or estimating story points for a new story. I kind of maybe think a 3-point story will take half a sprint, or a 5-point story might take a full sprint. So what do I think about this? Well, the machine learning algorithm did what I asked it to do. It sought out the mean and found an average for the data. So, is it a reasonable answer? Given the question I asked the algorithm, then yes. Is it different from the trend charts that we look at for our cycle time at the end of each sprint? A little bit, because when we're looking at trends, we're looking at our recent behavior, and this is showing all the stories for all the time. What it shows to me the most is that applying this line to the training set is nonsensical, and it's clear that even though it's found an average, we might like that level of predictability that every story of a given value should fit exactly on that line. It shows that there are many other factors which generate a high level of variance between the norm and circumstances applied. So this line through this training set is drawn with a complete lack of context. It's ignorant of whether we have more or less people at the time. It's ignorant of who changed over time in the team. So now on to my next experiment with machine learning. And so when we pick up a story in Connect Force, we use a template, which is like a formula for having a conversation about the value of the work we have to deliver. At the top of this is the user story, where we talk to our product owner about the value we want to deliver. And then once we've clarified that, we'll talk amongst the team about the scope of the work. So what should we do in the scope of this story, and what should we leave till later, or just say no to? And we also cover automation, given my lens, or non-functional considerations. So I have this idea that into the history of all our stories goes some of our domain language. And maybe some stories relate to one aspect of a product which might be more complex than another. So this seemed like something that I could break down past to a neural network, and maybe the neural network, if I trained it, could do the job of someone in the team and estimate a story point value for a new story. Evelina believes. So when you're learning machine learning, this Coursera course as an example given of how to implement a neural network, and it revolves around this data set of handwritten digits. What you do is you chop this grid up into 20 by 20 pixel images, and you feed that data to a neural network by unrolling the pixel values. It's grayscale, so each pixel is just one number. You unroll that into an array of 400 elements. And you give that as one training example to a neural network, along with the correct output value. And it's actually possible to train a neural network to 95% accuracy to predict which image you provided the network with. Oops. So I thought I could apply exactly the same thing to stories. So I decided that I would take all of the stories that I downloaded from the JIRA API, and I would iterate through their properties and throw away anything that was non-alphanumeric. Then I would split all the words and keep track of all those words in a kind of template object. After that, I would iterate through the stories again, and using that template object for each word, I would increment a counter. So I ended up with a CSV of 150 lines, where it's full of numbers, which are counts of words, and pass this to a neural network with the story point value as the output. And try to train that neural network to predict for future stories what the story point value should be. So a neural network is a machine learning algorithm that's based on the concept of neurons in the brain. And a neuron is an individual cell. Your brain has billions of them, which takes input-wise called dendrites, and then processes the input and spits out a new value at the axon. So a neural network is a way of implementing that in a computer. And it's very similar to linear regression in principle, but it's a lot more complicated. There's more maths and process involved. But the job of the machine learning algorithm is to learn the parameters for the network. This is the neural network cost function. I could break this down into detail, but I didn't get one. The way it works is that you take each training example and you always propagate it through the neural network with a random initial set of parameters. And that gives you a prediction for which class of output it should be. So is it a 1-point story, 2-point story, 8-point story? But then you compare that to the output, and you work backwards and evaluate a cost. Once you've done that, you pass the cost function and the initial gradients to an optimizing function. You run that iteratively, and it follows the same process of minimizing or optimizing the parameters to the neural network. So the result was an astounding 26% accuracy. So, you know, I felt like I reached a massive success. The first implementation of the neural network. So, you should try something, reflect on the outcome, and try to improve it. So, what could I do to improve the result? I need to get more story data to put through the network to train it to predict better. Or I could do more pre-processing on the inputs and use things like stemming, where you take tree and trees and they mean the same thing. Or there's other things I could do to the data, like term frequency, inverse document frequency, which is a way of lessening the relevance of terms like as or the or and, which occur frequently in all documents, and then lifting the relevance of terms like agent or supervisor, which would be part of my domain language and have more meaning. I could try a different neural network architecture with more layers, more nodes. I could iterate differently. I could tweak dials in the algorithms passed to the neural network. But again, this is all kind of just a bit silly. And the data I'm providing to the neural network is missing context. It's not joined up to people's knowledge and experience, and it has a very narrow view on the world. And this problem that I presented it with is not as clear cut as the one with the handwritten digits. Yeah. Building software is a complicated thing which relies on people working together, understanding, being able to generalize. So it's maybe a bit of a strange talk, but maybe it's not so much the content of the talk, which is my message, it's the learning, being excited by new concepts, and you know, when you're faced with something you don't understand, or the world is so flexible that you can break down those barriers and learn anything you like to. But we still need Scrum Masters, and we need people, and we're not quite ready to replace people with robots yet. Are there any questions?
Good one. When you talk, do you think that getting better training data is feasible for this context? And could you do things a bit better on continuous time?
So I think that it's a difficult one because I could get more data, but I have to go into the stats team. Like the more data I have, the more generic or more general it would be. And then that's it to tell me. So I think it's probably not an appropriate problem to be solving with machine learning. So, are you all familiar with Sesame Street? To me, building a presentation in PowerPoint was just something I couldn't tolerate. Because why would I've got all these skills to learn something, why would I open up a product in Microsoft? Waste hours doing things like but I built the presentation with React, and for training the neural network, I'm using something called Octave, which is a free version of NetApp, and is purpose built for numerical computing, and does like vector matrix multiplication reasoning. It's super easy. Actually, what was your biggest learning from this open school? My biggest learning, I think, is probably to think before doing, actually. One of the things I'll be honest about is I've invested a lot of time in myself and learning and kind of being quite indulgent in learning something new to me, and I think it's probably difficult to translate that to people's heads in a 30 to 40 minute talk at a conference. But I decided to carry on with what I was doing because there doesn't always need to be a conclusion reached on the day. So I think that I can share the experience. I don't know if you agree. Any others? You want to go for lunch?
There's a suggestion box by the door, and we'll be thankful for any.